Hi children, here I am going to explain you the theorems and important points related with the circles lesson. So first, let me say you about the tangent of a circle. So here we have a circle. So what is a tangent? Tangent to a circle is a line that intersects the circle at only one point. So remember that line children, at only one point. So here I am just keeping a point, and when I make a line which touches that only one point, then this line is known as tangent. So this line is touching the circle at only one point P. Now what is the theorem related with this tangent? So see here children. So I have a circle, and what is this line P? It touches the circle at only one point. So this line P is the tangent. Okay, so this line P is the tangent. And what is this line OP? OP is the radius. So what is that theorem? The tangent at any point of a circle is perpendicular to the radius through the point of contact. So here the point of contact is point P. So this radius will make 90 degree. Okay, so this is very important theorem which will be helpful for solving so many problems. So again, let me explain the same thing. So here we have a circle, and for the circle, here is the midpoint O, and this is the radius of the circle. And I am going to draw a tangential line. So tangent means the line which touches the circle at only one point. Both of them will make 90 degree with each other. Okay, so we know radius can be any way. For example, if I have a point here, and if I name the point of contact as OQ, then when I make a tangential line here, so let me give some name for that. So what will be OQR children? OQR will be 90 degree. Okay, so we can make anywhere. So the angle between the radius and the tangential line is 90 degree. Okay, so the angle between the radius and the tangential line is always 90 degree, or we can say it is perpendicular to each other. Now let's see the next theorem in the circle lesson. So we have a circle, and I have a common point outside the circle. I am naming it as A. Now from this point A, I am going to draw the tangent. So you know already tangent means it will touch the circle at only one point. So this is one tangent. It's my other tangent. So let me name it as P and C. So what we have done? We have a circle, and we have a common point A which is outside the circle, and I am drawing two tangents AB and AC. So what is that circle theorem? These two tangents are always equal. AB equal to AC. So how we can say this theorem? Tangents from a common point to the circle are always equal in length. So I will say again, children, tangents from a common point A to a circle are always equal, like AB equal to AC. So we can choose any common point which is outside. If I choose a common point outside, when I make like this, so BA equal to BC always. So if here I have a point which is outside the circle, and if it is touching like this, if I name it as P, Q and R, and always PQ equal to PR, because PQ is a tangent, PR is a tangent, where P is a common point which is outside the circle. Okay, so how it is written in our textbook? The length of tangents drawn from an external point to a circle are equal. Okay, so these are the two theorems which is given in your book, children. But for solving the problem, you have to recall all the theorems which you studied in your grade 9. Now let's see all important terms related with the circle. So what is the radius of the circle? The line. This is a circle. The line joining the center at any point to the circle. The line joining the center to any point of the circle is known as radius of the circle. Now, next term what you should know is chord. So, what is the chord? A line joining any 2 points on the circumference of the circle. So, like here I am taking these 2 points P and Q. The line PQ. Okay, so any line joining the points on the circle is known as chord. So what is a chord? Any line joining the 2 points on the circle is known as chord. So now children, can you tell me what is the biggest chord in a circle? Yes, it is the diameter. So diameter is the biggest chord in the circle. So it will pass through the center of the circle. So let's name this line as A and B. So AB is the diameter, which is the biggest chord of a circle. So now what are the terms you know, children? You know what is radius, and you know what is diameter, and you know what is chord. Now what is an arc? A piece of circle between the 2 points. Okay, so I'm just taking the 2 points. Let me name it as C and D. So what is the arc? A piece of circle. So this is the piece of circle which is known as a arc. Okay, children. So a piece of a circle between 2 points is called an arc. So how many arc we have here? Only one? No, we have two. See, we have one piece of circle and another piece of circle. And this is small, right? So there is a name for the small one. It is minor arc. And the big one is named as major arc. Okay, so we can name the arc also, children. So let me name it as P dash Q dash. So this P dash Q dash is the major arc, and this is also the part of that circle which is named as the minor arc. Okay. So now let's see the difference between the segment and the sector. What is the difference? Okay, so you know the length of the complete circle is called its circumference, and I am taking a chord. So what is a chord? We have seen already, the line which is joining any 2 points of the circle. Any 2 points of the circle is known as a chord, and the arcs are called segment. So here how many segments we have? 2 segments. One is small, the other is big. So the small one is named as minor segment. And the big one is known as major segment. Okay, so what is a segment? The region between the chord and either of the arc. The region between the chord and the arc is known as segment. So what is a sector? So the sector will be, let me explain with the same thing. The region between an arc and the 2 radii, that is the difference. The region between an arc and 2 radii joining the center to end points of the arc is called sector. So here, if we name this as OP and OQ, this is the minor sector. So sector means it is related with the radii. So you all know, children, radius is singular, radii, radii is plural. So here we have 2 radius, OP and OQ. So I am using the word radii. So the region between an arc and the 2 radii is known as sector. So this part is named as minor sector, and the other part is known as major sector. So you should be very clear with the concept, children. What is a segment? Minor segment, major segment. And what is a sector? And minor sector and major sector. Now let's recall the theorem what you have learned in grade 9, children, because you need this to solve any problem related with the circle. So what is a chord? Chord is the line joining any 2 points on a circle. You know that. Okay. So now I have a circle and I have 2 chords. So here I have the points A and B of the circle, and AB is the chord, and I have another chord C and D. So CD is another chord, because you all know what is a chord? A line joining any 2 points of the circle. So which is the biggest chord? The diameter. Okay, so here I have 2 equal chords. So I am naming it as A, B, C and D. So I am using the word 2 equal chords. So AB is equal to CD. here is the center of the circle. So these two equal chords will make same angle with the center. For example, if this is making 30-degree angle with the center, the chord CD will also make same angle 30-degree with the center. So just for example, I took the number 30-degree. So what is the theorem? Equal chords of a circle subtend equal angles at the center. Okay, so angle AOB is equal to angle COD. So how we can say the same thing in the other way? If the angles subtended by the chords of the circle at the center are equal, then the chords are equal. Okay, so if these angles are equal, then AB equal to CD. If AB equal to CD, then the angle at the center are equal. Okay. Now let's go for next theorem, children. So I have a circle and I have a chord AB. You know again, chord is the line joining any two points of the circle AB. Here I have the center of the circle O. The perpendicular line which I am drawing from the center of the circle will bisect the chord. Okay, it will bisect the chord. So AM equal to MB. Okay, so this is that theorem. So how we can say the theorem in other way? The line drawn from the center of the circle to bisect a chord is perpendicular to the chord. So this line is perpendicular to the chord. So OMB is 90 degree and OMA is also 90 degree. So n number of chords I can draw. Like if this is one chord and if I am drawing a perpendicular line from the center, so PQ will be equal to QR. Okay. So you have any idea, children, why it is perpendicular? Linear pair axiom, right? Its total is 180 degree, angle in a straight line is 180 degree. So 90 plus 90 is 180. Now let's see the next theorem, children. So I have a circle and I have two chords which are equal. So the length of these two chords are equal. So from the center of the circle, it may equal distance. Okay, so let's name it so it will be easy for you to understand. PQ is a chord, RS is a chord, PQ equal to RS. So when PQ equal to RS, OL equal to OM. The chords equidistant from the center of a circle are equal in length. I'll say again, the chords equidistant from the center of the circle are equal in length. Or what other way I can say? Equal chords. Like if PQ equal to RS, then OL equal to OM. If OL equal to OM, then PQ equal to RS. Okay. So this is our next theorem. Now let's see very important theorem of the circle. The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. So when we are reading the theorem, it looks very confused, right? Actually, the concept is very simple, children. See, the angle at the center. If this is 2x, this will be x. And what is that? I am saying this and this. This PQ is an arc. Okay. So, the angle subtended by the arc PQ to the center of the circle is 2 times the angle subtended by the same arc at any point on the circle. So this is the arc. The arc is making 2x with the center of the circle. Now with the same arc, I am making another line which touches any point on the circle. So if I measure that angle, that will be x. For example, if this is 100 degree, this will be 50 degree. Okay. So here arc is main, children. See, PQ is the arc. The angle subtended by an arc at the center. Okay. So this is the arc. And this arc is making angle 2x with the center of the circle. Now, the same arc, we are connecting it to any point on the circle. So, how much angle it will make? The half of that. This is 100, that will be 50 degree. Okay, so I can make at any point on the circle. So like if I make it here, then also I will join like this. So again the angle will be C. Okay, the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. So we are talking about this first picture, children. Okay. So the angle PBQ is double of the angle PAQ. Because POQ is the arc joined with the radius of the circle, and the line AP and AQ is the line joining with any point on the circle. Okay. Now the same thing, see the next diagram. Let me draw the same diagram here. I have a circle and I have an arc here. So this is the center point O, and I have an arc. Okay. So this is my arc P O Q. This is my arc. Okay. P O Q is my arc of the circle. So what will be this angle? This angle is going to be 2x. Okay, because this arc is making an angle with the center. Okay, so this will be 2x. Now, I am joining it with any point on the circle A. So what will be this angle? It will be x. Okay. So try to get the concept, children. So the angle subtended by an arc at the center. So this looks like semicircle, but you consider this is also a arc. PQ is a arc and the angle subtended by an arc to the center of the circle is double the angle subtended by the same at any other point in the circle. Okay, so this is what given in the second diagram. Now the third one. So we have a circle and this is the center and this is my radius of the circle and here is my arc. Okay, this big part. I'll put dot dot. Okay, so let me name it as P and Q. So this PQ is the arc. You can see that OP and OQ are the radius. So this is the angle. So this angle will be 2 times. Okay, always just look for the radius. Wherever you see the radius and it is connecting with the arc of the circle, it is 2x. Okay, now with the same point, I am joining it to any point on the circle. This is my arc. See, same like the first one, children. See, PQ is the arc. First I joined it to the center of the circle. Next I join it to the any point on the circle. Same thing here also. First I join with the center of the circle. Then I join with any point on the circle. Okay. So according to the rule, this will be x degree. Okay. So this is named as reflex angle. The reflex angle POQ is 2 times the angle PAQ. Okay. So just get this concept, children, then everything will be easy. PQ is the arc. From the arc, when we are connecting with the radius of the circle, it is 2 times. Then I am connecting the same arc with any point on the circle, that will be x. Same concept only here also. OP and OQ are the radius and this is the arc. So this will be twice. Now I am connecting the same thing with any point on the circle and that will be x. So this is the segment of the circle. So we have seen already, like this is the minor segment and this is a major segment. So this theorem is angles in the same segment of a circle are equal. So if PQ is the segment, when I connect this angle, if I join like this angle, if I join like this angle, all these angles are equal. So angles in the same segment of a circle are equal. Now let's see the last theorem. This is very important, children. Cyclic quadrilateral. So I have 4 points. This is a quadrilateral A, B, C, D. This ABCD quadrilateral is called cyclic quadrilateral if its vertices lie on the circle. If its 4 vertices lie on the circle, then it is known as a cyclic quadrilateral. So what is the rule here? Opposite angle sum is 180 degree. Angle A plus angle C. is 180 degree. The sum of either pair of opposite angles of the cyclic quadrilateral is 180 degree. Or we can say, if the sum of the pair of opposite angle is 180 degree, then the given quadrilateral is cyclic quadrilateral. Okay children, this is a very important theorem. Now, one more thing which is very important regarding the grade 10 is, see here, I have a quadrilateral. Inside this quadrilateral, I have a circle. And I am naming the quadrilateral ABCD, and this is my circle PQRS. See the difference children? Here we have a circle. Inside the circle we have a quadrilateral. Here it is in the other way. We have a quadrilateral. Then inside we have a circle. So what is that theorem? A quadrilateral ABCD is drawn to circumscribe a circle. Means around a circle. When we have drawn a quadrilateral, the opposite sides, when you add AB plus CD will be equal to AD plus CB. So at least one problem will come using this point children. So don't get confused yourself. So this is different and this is different.